The next type of relationship we are going to look at is an actual equation. So let's kind of flip through example 2 here. If you scroll down, you can see that we are going to be given equations. So in example 2a, the equation is y equals 3x minus 2 all over 5 minus x. And then if you flip the page to example 2b, you will see 2x squared plus 3y squared equals 1 as our equation. And the question is going to be, given this equation, is it a function? Okay, so let's go back to the middle of page 2, and there are some instructions on how to determine whether an equation is a function. All right, to determine if an equation involving the variables x and y defines y as a function of x, you're first going to solve for y in terms of x, if necessary. And then you're going to examine the resulting equation to determine the number of y values produced by plugging in a single x value. If the resulting equation is a rule that gives one value of y for each value of x, then the equation does define y as a function of x. On the flip side, if the resulting equation is a rule that gives more than one value of y for each value of x, then the equation does not define y as a function of x. Okay, so that may be a lot for you to process. Okay, so hopefully doing an example or two will help you out here. Okay, so let's go down to example 2. The directions say determine whether each equation defines y as a function of x. Okay, all that means is given this equation, does it represent a function? Okay, so the first thing that the directions said to do was you need to solve for y. Okay, so what that means here, and I'll go above here in the instructions and jot that down. You want your equation to look like this. It's got to have y equals on one side, and then the other side can only have x's. Okay, so you need to be able to get it in that format. Okay, if it isn't already, you need to make sure before working with the equation that it looks like y equals, and whatever's on the other side, is complicated or as simple as it is, it can only have x's. So if we go down to the equation in example 2a, this equation is already solved for y. Okay, we've got y equals on the left side, and then on the right side we only have x's. There aren't any y's over there. All right, so once your equation is solved for y, you can work with it and try to determine, whether or not this is a function. Okay, what we're going to do is we're going to plug in x values. Okay, so we're going to plug in x values. We're always in charge of x. Okay, and you can plug in anything you want. Okay, for the most part. Okay, and we are going to try to figure out, does every input have a single output? Okay, we know that x values are our inputs, okay, and y values are our outputs. Okay, so we're going to take random x values, plug them in, and see every time you plug something in, do you get just a single output? Okay, all right, so again, we're trying to answer, does every input have a single output? Oops, hang on. All right, so let's try this. All right, that's the question we're trying to answer. Does every x value that you plug in have a single output or y value? Okay, and again, you can pick pretty much whatever you want. I'm going to start by picking x equals 0. Okay, so I'm going to plug that into the equation. So everywhere I see an x, I'm going to replace it with 0. So in the numerator, the top of the fraction, we're going to get 3 times 0 minus 2. Over in the bottom or denominator, we're going to get 5 minus 0. If I simplify this, this is going to give me -2 in the top and 5 in the bottom. Okay, so that tells me that an input of 0 gives me an output of -2/5. Okay, now it doesn't really matter that you got -2/5 as your output. What matters here is that you plug something in and you got 1 output. Okay, so if you tried this again, you might be concerned, well, maybe it's because I picked 0 for my x value. Okay, so let's just pick something else. Okay, maybe 1. So if I plug in x equals 1 to the equation, we're going to get y equals 3 times 1 minus 2 over 5 minus 1. That's going to tell us this is going to equal, in the numerator, 3 minus 2 is 1. The bottom, 5 minus 1 is 4. So an input of 1 gives us an output of 1/4 or 0.25. Okay, this is again 1 output. Okay, so, and you can try other things if you're still not convinced. Okay, every time you pick an x value, you're going to get a single output. Okay, so this is a function. Okay, every input has a single output.